Okay, so let's try a problem where we've got something like, I'll just pick up some test data here. Here's a bunch of students. And I've got these students in basically a static array, so this is just some test data. And the students have come along through the course of getting registered for the class, and they've walked in and they've told me that they wanted to be registered. Okay? The only problem is that I've got, so this is their name and this is their social insurance number, and notice that I've got two different Bobs because they have different social insurance numbers. But I've also got one person who can't decide what their name is, and so every time I talk to them, they give me a different alias. So the first time they say they're Joe and they give me their social insurance number. Someplace along the line they say they're Joseph and they give me their social insurance number. And oh, look, it's the same one. And then they decide that sometimes they call themselves Jojo, so it's there 3 times. Okay? So the problem is basically what I want to do is boil that list down to all of the people who are unique. No duplicates. So how should we go about doing that is the question. We're looking for something that eliminates or replaces duplicates. There's your hint. If we put these into a hash table, what happens to duplicates?
They get overwritten.
They get overwritten, so the last one shows up, right? So it's just like an array, right? We said yesterday, you put in the first entry and it fills the array position. You put in a different entry in that array position, it's wiped out what was there before. And so what you'll end up with, if you dump these things into a hash table, is just the last one of those things in there, and he'll clobber himself every time with that social insurance number. Okay? So the unique thing here is the social insurance number, and the thing that doesn't matter is the name. Okay? So I'm going to put these things into a hash table to start with. So let me go and make a hash table, which is map uniques equals new, what's it called? Hash map on a good day. So this would be my hash map. What sorts of things are we going to put into the hash map? Remember, maps are special. They have both a key and a value. So what's the key going to be? In a little bit more general than that. When the student comes in the door, if I'm trying to find information about them, I'm going to ask them for their social insurance number, because that's going to be the unique thing. And when I get their social insurance number, I'm going to put them into my map, so think of it as an array, based on whatever number they give me. So this is the one where the thing that I'm given as a key is just a student. That's the unique thing. And the thing that goes into the table at that position is also a student. And I'm going to make sure that I get let's just do, yeah, look, there's my import statement. That should be fine. I've got a few here that I just used leftover stuff. I guess I could say new would be helpful. Okay, so if we're going to put students into this table, this is the key. Student's going to tell me what's unique about them, and when we put them in, we're going to record all of their information. Okay, what does the key have to have in order for this hash table to work? Okay, so remember, in order for, if you look at our code and see what we did to put stuff into our hash table, the very first thing that we did was we took that object and we called object's hash code in order to figure out what was unique about it. Give me a number that represents you. Okay, so student needs a hash code method. What else does it need? It needs an equals method, because when they're in the table, you might have more than one thing at the same position in the table. So after when we're trying to put them in the table, we ran through to make sure that they didn't already exist in the table. So we ran an equals across the chain of things. So the bottom line here is, if this first parameter is ever anything but string, so it's one of your classes, chances are pretty good your student class had better have a hash code and equals method in it. And so we'll just go bring up student and see if I was kind enough to do that for you. And so here's a student class, which that should be marked as public. And there's no hash code or equals. So let's write one. So the hash code method should return an integer. What's the unique thing about this student? Social insurance number. So that should be the unique thing. And equals can be the same thing. So the rule is they should always be the same thing. So we'll make equals take in another student. And then we'll return my social insurance number. And since it's an integer, it's minus, sorry, that would be compared to, return other, or my social insurance number is the same as other dot social insurance number. Okay. So there's a hash code and an equals. Got that all set up to go. How do you add them to the table? Want to use a for each probably. So here's for each student who in all of the students that are test data talk to the uniques table and say, put that student into the table. What's the key? Who? What's the value? So, I mean, the translation for this is ask the student to give something unique about themselves, which in this case they're giving the social insurance number, and when they give you their social insurance number, use that thing as where you put their information into the table, at what array position they go into. Okay, so that dumps them all into the table. Now, how do you print them out? Suppose we wanted to see what we've got left. this gets tricky. Now, the short answer is, oh, well, I could just use an iterator and go through this table. But when you try to use an iterator, it says, no, sorry, hash table doesn't have an iterator. Which seems sort of strange. You'd think it would, because most of these Java collections have iterators. Turns out it doesn't have one, it has three. So, when we put things into the table, we put two things into the table that we pair up. So if you think of it as being something like a dictionary, you've got the word and the explanation for the word, and you pair those two together. So if you think about, I want to print out stuff from the dictionary, there's three combinations of things that you can print out. You can print out all the words in the dictionary. You can print out all the word and definition pairs in the dictionary. Or for some strange reason, if you really wanted to, you could just print out all of the definitions and no words. Okay? So three different ways of going through that thing, which is why this thing doesn't give you an iterator. Okay? So what do you want to see first? Pairs sort of don't make any sense here. Keys don't make any sense because the keys would just be the social insurance number. I guess keys and values are going to be the same thing. So how about if we try doing that with uniques dot, let's just have a look here. Here's our choices. The thing that's labeled there as entry set is all of the unique pairs of things. Okay. The thing that's labeled as key set is just the keys, and the thing that's labeled as, where's the other one? Values is all of the values. Okay, so you have to be specific with hash table. It's a little bit different than all of the rest of the collections. You have to be specific about which one of those you want to go through. So you can say, go through all of the values in the table, for instance. And so then we could do system.out.println who dot get first name. If we print this out, what do you expect to see? How many things do you expect to see printed out? There's 6 things in total right now, but 2 of them are duplicates, so you should only see 4 things printed out if you're lucky. What order are they going to come out in? So arbitrary order, don't know, right, because they go into the hash table in any old order, so it just goes through the table. So that was order, yeah, sure. Duplicates or no duplicates? Is it going to keep duplicates or throw them away? It's going to overwrite them. That's what we said at the beginning, because it's just like an array. It overwrites whatever's at that position. So if you think of the social insurance numbers as being array positions, it's going to overwrite them. What's the for the social insurance number for Joe, Joseph, Jojo? Which name is going to show up? Jojo, the last one. Okay, so let's give it a try and see what happens. So there's 4 entries. There's only the last Joe entry, and there's 2 Bobs because the Bobs have different social insurance numbers. So if we actually print out their social insurance number, that might be better. Just so that we can see that they're different creatures. And there you go. Okay? So that's a very common little trick to play. And hash table makes this really, really, really efficient to do this because the cost of putting them into the table is negligible. It basically behaves just like an array. You can index things at whatever position in the array pretty much directly. It's not like you're searching through them, searching through this list repetitively in order to do that. Okay, questions about that one? Okay, let me see if I can make it a little bit more tricky then. Suppose that I want to not only record the unique people, but I also want to keep track of how many times I've seen them. So in this case, I want to also retain the fact that I've seen Joseph/Joe/Jojo 3 times. So I want a table that just shows the name of the person, their social insurance number, and the number of times that I've seen them. How about that one? What 2 pieces of information am I trying to group together? Well, in this case, the student, the unique student, and the number of times that I've seen them. Okay? So there's a pairing of 2 pieces of information, student, number of times seen. Okay? So let's make a map that has the student paired against the number of times seen. Here you would like to say integer, but you can't, because the only thing that Java is going to allow you to put into these collections is something that's an object. So what can we use instead? Big I int will work just fine there. So it's a pairing of students with the number of times that that student has been seen. So we'll call this the time seen thing, and we'll make it a new hash map. And now we have to add all of these things into the table. So we'll go through all of the students, just like we did with this one, and we'll attempt to put them in the table. Okay. But this time we're not putting them into uniques, we're putting them into times seen. And now the compiler complains and it says, well, hold it, the first parameter is right, it's student, but you said that this second parameter was going to be an integer. Okay, so we have to put some sort of number in there. By the way, why does the 0 work there? This is a little I int, but the thing that we've said that's going into the table is a big I int. Yeah, there's an actual conversion. In the old days in Java 6, you would have to write this to get it to work. So you would actually literally have to take the small I integer, wrap it into a big I integer, and then stuff that object into the table. But in Java 7, they introduced this feature that they call autoboxing, and autobox means take that little I integer and box it into a big object so that you can actually use it. Okay? So that would work, for instance, to say, I've just seen that person once. But there's a but here. That's true the first time, but what if you see them the second time? This would just, every time you see them, associate them with the number 1. So this is actually a special case. If it's the first time for them, then they should get the number 1. Otherwise, for any other time, we should increment them based on their number before. Which means we're going to have to do what with them? How do we know whether or not to increment them?
Search for them in the hash map.
You have to search for them first. So the trick here is that we're going to go search to see if they're already in the table. So we'll do student found is talk to times seen and do a get, and the thing that we're going to retrieve is that person to see whether or not they're already in the table. I think I did that right. Let's just see what's it upset about. Oh yeah, what you get back is just a number. Do that right? Oops. I'm just looking at this and then going, something a little weird about this, but that's okay. So if seen happens to be, we'll give this a try, 0, then we would put them in the table as being, oops, stop that, as seen once, and we would say, we're done. So I'm going to write that as if it was a rejection. Otherwise, what would you do? What's the normal case?
0.
Normal case is if there's a whole bunch of duplicates, they've already been seen a whole bunch of times. So if they've been seen 5 times, what would you do? Seen them again, it should be 6. So if they're already, what you can do is you can do seen plus plus, seen them one more time, and then put them back into the table. Which is, where's my table here? Times seen dot put, and I'm going to put the same student back into the table, but this time I'm going to put them in having one extra number. So this one bumps up the number and then replaces that particular student in the table again with the new number. Pairs them up with a different number that's one higher than the older number. Okay? By the way, this little pattern is really, really, really common in a lot of code. This idea, oh, if it's the first time, excuse me, I do something special, for every other time I do this regular thing. Okay? You see that over and over and over again in code. How will we know it worked? Let's just print some stuff out here. So we have a blank line with that other stuff. We need to go through everything in the map. What do you want out of the map? 3 different options. You want both, right? Because you paired the 2 things together, so we want to see both the student along with the pairing of the number, which means we want what we call the pair of things, both at once out of the table, okay, the grouping, okay? So let's just do it this way for a second. We'll have to fix this, go through the time seen table. And the thing that you want is entry set, because that thing is the pairing of student to integer. And notice that what we called a pair, Java actually calls in their library an entry. Same thing. And so now what you get back, in case you didn't see that, is that thing there, set entry student integer thing, right? So let's just put that in here. Set student integer pair of things. We'll fix that in a moment and see if I did that right. For each entry of student integer, got it in that thing, entry set. We're going to do something. And it's not going to like that thing that's coming from Java util map is where that thing is. There we go. Okay. And then we want to print out and we'll print out the name, I guess. So that's actually, let's just do it this way. Let's split them out. So we'll get the key out of the pair. We'll get the value out of the pair, just because it's easier to deal with the pieces separately. And now we can print out who dot get first name plus who dot get social insurance number plus times. Okay. Save it. Run it. Oops. Null pointer exception. Only the easy thing to do is go, okay, it's happening at this line. Why is that giving a null pointer exception? this one's really subtle. Remember what I said about what happens here on this side. What's the thing that's coming out of the table? The thing that's actually coming out of the table here is a big I int. Okay? And what if they're not in the table? Then the big I int that you get, if we just make this integer, what's the hash table going to give you back if it's never been seen before? It gives you a null back. Okay? And so what then we're then trying to do is we're trying to use the null to do something, and it doesn't work. So the longer version of this is it's actually int scene equals talk to the scene object and do a give me your integer value, and then this would be if int scene equals 0, I'll just change these, int scene plus plus, put in int scene. I'm just going to do the longer version of this thing so that you can see what's happening. So sometimes your autoboxing isn't your friend because it hides things that make life non-obvious. And so what I'm going to do is I'm going to do it the long way just to show you. I'm going to go get that big I integer out of the table, and then I'm going to convert it into a little I integer, right? And so this thing now needs to go down here. We'll put the conversion down there, and we'll do the check here to say if scene happens to be null, then we'll put them into the table with a 1. Okay? So there's the slightly longer version that tries to make it obvious what the weirdity is. Now we'll give it a try. And there's times seen. And there's Joe with the number 3 beside him. Okay, so there's 2 really typical usages for hash tables so far. You can use it to throw away duplicates if you don't have any interest in them, or if you want to count them, you just do a different pairing, which is the thing versus the number of times that you've seen it. And there's that idea that also with hash tables is that you typically see quite often just a temporary pairing. These 2 things don't normally belong together, but in this case I have reason to group them together. Right? So you don't need a variable that in student that counts the total number of students, a static variable. It's just on this occasion we somehow need it, so we'll just pair them up and do the counting that way.
Would it be that much more difficult to retain the count, but to have the last name, not the last name as in the person's last name, but the last time you've seen him? So Joe would be called Jojo instead, because that was the last name he provided to you?
That's the one that you're going to get.
But it says Joe.
Oh, yeah, okay. The reason it says Joe in this case is because the first one gets counted, right? They're in the table with the first one, and so we're not changing the name, we're changing the value.
Would it be that much more difficult to update the name at the time that you're counting?
Kind of if you want. If there was a need for it, you could update it. But in this case, it's just not doing that. Because you're just basically updating the old one. But yeah, if you want to, flip it around and put the new one in its place. Doesn't matter. Okay? So there's 2 usages. We'll look at one more usage of hash tables tomorrow, and then we'll also look at some of the fancy things that you can do with the Java trees tomorrow, including one interesting and exciting thing that you've never ever seen before. And with that, we're done.